Assalamu alaikum. How are you, students? Here is your teacher Muhammad Ikram from Pakistan International School, Thai. Our today lecture is the summary of the chapter Work and Energy, and inshallah at the end of the summary I will do some part of the exercise to you also. Rather, I will teach you how to do the exercise yourself. So let us start in this chapter. We have learned few important physical quantities like work, now work, energy, efficiency and power. What is work? Work, I told you that work is in fact the method of transfer of energy. Work tells us that how energy is transferred from one place into another. Rather, we can say that work is done when force acts on a body and displaces it in the direction of the force. I'm not making any drawing or anything because it is just a kind of summary. There are a lot of videos regarding this chapter available to you. Okay, so you see that work is done when force acts on a body and displaces it in a direction of force. But the concept of the work is, I told you that work is done when energy is converted from one form into another. If this thing happens in a process, then we say that work is done, otherwise not. So work is in fact the method of transfer of energy. But in this kind of transfer of energy, there involve the movement of the body, right? And I'll be coming to that point. This work, there are two kind of situation. Work done by a constant force as well as work done by a variable force, right? Second, work done when force and displacement both are parallel to each other. If you remember, that was work done equals F into S, right? And then there was a situation where the work and force both are related with some angle theta with each other. That is, the force and displacement were not completely in the same direction. Force, displacement, and then there was an angle. And then at that point, we arrive that work done equals force displacement into cosine of the angle between them, right? It was when both parallel to each other. It was when there was an angle. Then I told you that work done will be zero if force and displacement are at right angle to each other, and in that case no work will be done. So work will be done, that is, when you have the force and when you have the displacement, and moreover force and displacement are parallel to each other. If is zero, work done will be zero. If displacement is zero, still work done will be what? The work that is, and S is not equal to zero. Work done will be zero. Here, rather let me do it in a sequence. That would be better. Look, work done, that is F. F is equal to zero, and S displacement is not equal to zero. Rather, then at that case, work done will be equal to what? The work done will be equal to zero. For example, if there is a body and if the body moves with a constant speed, right? on a uniform straight road, then there is displacement, but there is no force acting on the system and the work done is zero. One case. Then I told that okay, if there is force is not zero, but the displacement is zero. You see, look, your displacement is zero and force is not zero. Then it's still at that stage, the work done will be what? The work done will be again zero. Why? For example, a car with its engine running, but the car is not moving. That is when you start or switch on the engine of the car, it exerts some force, but what? The displacement is zero and there is what? There is no work done. For example, just pushing on the wall, you exert a force on the wall, but what? The wall is not displacing and then the work done is zero. Similarly, then I told you about another case mostly related to this, that neither the force is zero nor the displacement is zero, but still we can have the work done zero. When the angle between force and displacement is 90 degree, and that will lead to a zero work done. When, for example, look, the work done by gravity, that if you have to carry a basket of water, for example, look, then the gravitational force acting on the basket is in the downward direction. That is gravity, force exerted by the gravity, m into g, weight, right? And for example, this is point A, and let you displace this to another point at the same height, the basket height the same, not changing like this, to a new position B. As you see, this is the new position B of the basket with still the same weight, right? Equals mg. And this is how you have made a displacement. So you see, as the force and displacement are at right angle, so the force, remember, the force done by gravity on the basket, this force does a zero work done, no work done. Why? Because cos of 90 is what? Zero. So the work done will be zero. So that is what, that when you carry a basket of that is a bucket of water, rather I would say bucket of water, and look, along the same height and to some distance s, then the work done by gravity, remember I said the work done by gravity, not by, that is zero. Why? Because the potential energy of the basket is not changing with respect to the ground. It has the same height, h, and it has what? The same height. Now you know much about the potential energy. So here you have mgh and here you have also mgh, the same potential energy. Why? Because the level of the bucket is not changing, it is the same height, right? So there is no change of energy. The potential energy of the bucket is not changing into any other form, it is constant. So no work done. Why? Because the concept of the work is what? Work is done when energy is changing from one form to another. Yes, you do work. Why? Because your muscle is constantly contracting and expanding. Why? Because as you carry the bucket, what happens? That your muscles exert some force right on the bucket to carry it forward. So there is constant contraction and expansion of your muscles in the direction of the force exerted, right? And therefore you feel the discomfort of doing some work. So, but the gravity does not do any work. When the gravity does work, for example, when you raise the bucket of water to certain height, when you raise it in this direction, for example, let us see you try to pick it in this direction. As you see, look, if you want to raise it from this point C to another point D, so during this vertical raise, the gravity does some work, right? Why? Because there is displacement and there is what? And there is force, right? Yeah, when, for example, when the bucket fall from this height h back to the ground, then the gravity does work. Why? Because displacement also in the downward direction and the force is also in the downward direction. Now a negative force that is beyond the syllabus or beyond the scope of your course, so the negative work done we will discuss in some higher classes, although the gravity, there can be a negative work done also. So that is all about the work done. That work is done when energy is converted from one form into another, Now let us talk about energy. We have then another physical quantity which is energy. Remember, work is measured in joule, okay, Newton per meter. This is what you already know, but I just want to repeat to you the basics and the differences. So this was all about work. Now you know about what the energy. That what is energy? Energy, as I told you, that the kind of physical quantity which is the ability of the body to do work, or the capacity of the body to do work, right? When you have energy, then you have the ability and the capability to do work. If you are without energy, then you don't be able even to write something on the board, right? Every job produce energy, or every job requires energy. Or in another way, I'll tell you that if you have energy, then you have the ability to create or to produce force. For example, look, I have the energy, then I have the ability to displace this board, as you see the displacement of the board towards the camera, as you see. So this is why, because I have energy. I have energy and I have what? The ability to do work. So you see, I apply a force in this direction, and there is displacement in this direction. How I can apply a force? Because I have energy. If I'm sick, weak, and then I wouldn't be able even to move it in an inch, right? So that is energy. Now the energy is usually, there is various kind of energies, but broad classification is mechanical and non-mechanical. Mechanical energy was the main theme in our this chapter, and mechanical energy comes in two ways: either the kinetic energy or the potential energy. And this potential energy is also of two types: gravitational potential energy and elastic potential energy. Kinetic energy, if you remember, I told you that it is the natural or the intrinsic properties of all the moving object. The natural are the intrinsic properties of all the moving object. Whenever that is, whether the object is slow or fast, big or small, doesn't matter. There is the kinetic energy is associated with all the moving objects. If the body move, doesn't matter what kind of motion the body has, then there will be a kinetic energy associated with the body. And I told you that in the previous lectures that kinetic energy, in fact, directly proportional to the mass of the object. If you double the mass of the object, the kinetic energy get double, right? And the kinetic energy is directly proportional to the square of the speed, right? Double the speed and the kinetic energy will increase 4 times, right? That it is directly proportional to the square of the speed. It is for constant velocity and it is for constant mass. For example, if we want to study the effect, then keeping mass constant, velocity constant, kinetic energy directly proportional to mass. Keeping the mass constant, kinetic energy directly proportional to the square of the velocity, right? So this is how you see the kinetic energy is that if you double the speed, kinetic energy will increase 4 times. If you increase the velocity 3 times, kinetic energy will increase 9 times. Similarly, by using this relationship, we can just interlink this with the momentum also, and we can find the velocity by knowing the energy also, and how the velocity can be. It will be twice the kinetic energy mass, that is by mass square root. We can use this effect also. Similarly, if you just want to know that the kinetic energy, if I just, you can express it in terms of momentum also, because energy and momentum are very closely interlinked together, right? How? For example, you just see, look, twice the kinetic energy as you see, and look, it will be mv square. If you multiply both sides by mass, so 2 times kinetic energy mass it will be m square, and what will happen? Like this, m square v square, and you already know mv is momentum, so it will be 2m into kinetic energy into p square, right? So another interesting relationship, that momentum is equal what? It is equal to twice the mass into the kinetic, the product of twice the mass of the body, and it's the kinetic energy possessed by the body. That is the momentum. This will work better in your MCQ. Similarly, if you want to see what will be your, that is, what will be the kinetic energy? The kinetic energy is what? It is the p square by what? By 2m. That will be the kinetic energy, that it is directly it is equal to the square of the momentum the object possesses by twice the mass of that object. So that is the kinetic energy relationship. Similarly, the potential energy, it is due to the configuration or the position of the object. For example, there is two kind of energy, the gravitational potential energy. What is gravitational potential energy? This kind of potential energy is the energy possessed by the body when it is stored in a body, when it is raised against the gravity. So whenever you raise an object, for example, look from the bottom of this whiteboard to the top of the whiteboard. So the marker has energy with respect to the ground, potential energy is with respect to this bottom of the board. So look, that is how the potential energy, gravitational potential energy is. The body has the gravitational potential energy when it is raised against the gravity. Similarly, the elastic potential energy, it is the energy possessed by the body due to its configuration. For example, it is that when its geometric structure is changed, rather I would like the energy stored in a body due to deformation in a body. For example, when the body is being stretched or the body is being stretched or compressed, just like a spring or a rubber band or the bow, right? So that is when you deform the body, then the body has what? The potential, the elastic potential energy, right? Usually that energy comes from when you just disturb the geometric structure of the atoms and molecules of the body. Sorry. So the body have the elastic potential energy. There are various formulas for the elastic potential energy. I'm not mentioning either because that is not the part of your scheme or syllabus. So the elastic potential energy always comes from those effects. When you bend, right? When you stretch or when you compress the bodies, then the body have a potential energy stored in it. But this potential energy is usually that it is a kind of the potential energy, that is rather a kind of energy bank usually. Here energy is stored. It is then available to us whenever we want. For example, look, if you raise it to the top, the energy is now stored in this marker. Whenever the marker get a chance or when you release or drop, then we will get that energy back, and that potential energy will be converted into kinetic energy or heat energy or sound energy is appropriate. So that is all about the energy. Then there is efficiency. The efficiency, as I told you, the efficiency describes what? The efficiency tells us about the usefulness of the machine, that how much the machine is useful while converting the energy, the input energy into a useful work done, and that was percent efficiency. It was the ratio of output to input multiplied by 100%. And if you see, as I told, that the output to input into that is the work done by the machine, this is the work done on the machine. More appropriately, I told you that this is the power out, this is the power in, the input power, the output power into 100, best we can express in this. And then I told you that it tells you that how much the input energy is converted into useful work done. The greater the efficiency, the lesser the energy wastage will be, the less the energy will be wasted, right? So efficiency actually describes the maximum use of the energy from its source, right? Then I told you about the machine also. The machine involves between output and input, but the machine neither store energy nor it can increase or decrease the amount of work done, right? Nor the machine has the sources of energy. The machine only make your work easier by transferring force from one place to another, or by performing your job quickly or faster, right? That can be load advantage also, to lift heavy load. That can be a speed advantage also, to provide you more speed. So in various ways they can be done. So that is the efficiency, right? And then I told you about the power also. And for the power, I told you that power is the ratio of, it is what? It is the ratio of the work done to the time taken in which the work is done. Yeah, I told you that work, it is power is what into that is W by T. Here I told that it has no unit. It is a pure number less than 1. For all the real machine, efficiency is less than 1, while power does not. Power may be greater than 1, right? Both are positive, but for mechanical powers are positive. So it can be, that is, efficiency can be less than 1 or less than 100%. It cannot be 1. It can only be 1 for ideal kind of machine, which does not exist, which convert all of the input energy into a useful work done. While power, which may be greater than 1, it could be in megawatt, it could be in the gigawatt also, right? So power, there is intricate differences between the two. The power, they tell that how much your machine is useful in converting your input energy, the energy from your source, into a useful work done. It emphasizes on less wastage of energy. That is efficiency. While power, remember, power does not care for such thing. A machine may have a greater power, but it may have a less efficiency. One simple example I will give you. For example, a car engine. The car engine is 35 to 40%. This is the efficiency of your car engine. How less is it? Oh, rather about 60% of the energy is being wasted. The energy resources from, if you produce 100, or if you are available 100% energy sources, right? Heat energy or chemical energy. Your car engine consumes 35% in useful work done. The rest is wasted against overcoming friction, producing sound, producing unnecessary or undesirable heat. But the power of your car engine is too great. That is in the megawatt, in the gigawatt, in the megawatt, right? They can produce, they can have that much produced, right? That much power it has. So that has the ability to take you to your destination very quickly, very early. For example, if you take 7 days by your feet, your car will maybe taking 7 hours to take you there to your destination. So there is a big difference between power and efficiency. Efficiency tell you how useful your machine is, how much of the input resources it can utilize to produce the maximum output, to waste less. Power does not care for something. Power tells that how fast it can does a particular work. So that is the difference between the two. Power is measured in watt, or in the horsepower. There is horsepower also in the British unit of power, thermal engineering, and it has no unit. Why? Because it is the ratio between two similar things. So that is the difference between efficiency and power. So work and energy, there is intricate difference between the two, right? That work is in fact the method of transfer of energy, while energy is the capacity or the ability to produce force in one way, or to cause force. And there is a difference between efficiency and power also. So these were the four major points of this chapter. So that was the summary. Now let us just move on to the exercise. If you have your physics books, place in front of you, right? And if you see, look, if you open your book at page 142, for example, look at numerical 6.1 and 6.1. For example, these are so easy as eating ice cream or just like watching a TV. If you see, look, a man has pulled a cart through 35 meter, applying a force of 300 Newton. Find the work done by the man. So if you just look to the data, how you can extract the data from it? A man has pulled a cart through 35 meter, applying a force of 300 Newton. Find the work done. So very easy. Displacement is given 35 meter. The force applied, it is how much? 300 Newton. And they ask you to calculate the work done. So easy. What is the work done? F into S. So you just put the appropriate value, 35 meter and 300 Newton, and you will get the required answer. And of course the answer will be in joule. Hope you will finish it yourself. Now let us move on to the next question. As you see, in the next question, they are telling to you that a block weighing 20 Newton is lifted 6 meter vertically upward. Calculate the potential energy stored in it. So you see the weight is given. In 6.2, you have been given the weight of the object. Like this, W small w. Weight of the object is given mg. And what is that weight lifted? It is 20 Newton. And they tells you the weight lifted to a height of what? 6 meter. Height is 6 meter. So they ask you what will be the potential energy. So of course you know potential energy is mgh. So you see that, look, you have already the mgh equivalent given here, like this 20 Newton, and you have the height. So you have the right answer here in joule. So that is your 6.2, for example. Let us see a 6.3. A car weighing 12 kilonewton has a speed of 20 meter per second. Find its kinetic energy. So the force is given, the speed is given, and they ask you about the kinetic energy. The speed of the car is given. Sorry. The weight of the car. A car weighing 12 kilonewton has speed of 20 meter per second. So weight of the car W. It is 12 kilonewton. Right? It travels with which speed? It travels with the speed of what? With the speed of 20 meter per second. They ask you for the kinetic energy associated with your car. So what is the kinetic energy associated with your car? The kinetic energy is in fact equals half mv square. So do you have the mass in the data? You don't have. But don't worry, it is very easy. Look, you have the weight here. So weight is mg. So look, what is your m? It is equal to w by g. Right? So just go find the mass from this equation. Rather, if you don't do this, no problem. W g v square. And here you have a new formula. If you know the weight of your car, then the kinetic energy associated with it will be this one. This is not a work done, remember. This is small w, weight of the car. You see, look. So you can have this formula. Even so, you can make your own formulas like this. Okay, into the simplified form. So that is how for the energy is. So we have question on the potential energy, we have on the work done, right? Similarly, we have on the kinetic energy and the potential energy. I should find a question for you in the power section also. So I just want to find out this question. Where is it? Let me. Okay. There is another question. 6.9. It is rather 6.9 based on power. Calculate the power of a pump which can lift 200 kilogram of water. That is mass of the water that is lifted 200 kilogram, and the water is lifted to the height of 6 meter. Look, much part of our last lecture. So you see second last. So you see that look, the time taken, it is 10 seconds. So they tell you that find the power. For such situation where height is involved, I told you how we can calculate the power of the motor like this. mgh by t. Right? So work done by time. This is force, so force, height, this is displacement. So work done into time. So you have the mass, you have everything with you. Okay, and you can calculate the power. Right? So that is all about the power. I think there is no numerical on the efficiency, but I'm pretty sure that you can check the example given in the numerical, that is the example given at the end of the topic efficiency. I'm sure that there is one, so you can see that as a reference. So class, thank you very much. This is all the syllabus or the scheme before the summer vacation, and today we have finished this task. So thank you very much for staying with us, and thank you very much for all the online classes you have joined in this COVID-19 world, right? And wish you all the best. Thank you very much. And if you have any question, any queries, then you can see me on the Zoom. So at the time allotted to you or the time mentioned, so you can ask your question. You can reach me through my WhatsApp number also, as you already know. So I will entertain your question there, because you know that I always believe, strongly believe, on a class which starts at the question and which ends at the question, right? So then my question for you will be that I'll be asking question, the most important question, like what is the difference between work and energy, efficiency and power, like that. Okay, so thank you very much.